Nice, everything looks clear. Sweet. All right, number 7. Exam worksheet. Let's go. This one, negative cosine theta minus sine. And then trig, when you're looking at trig at a certain point, you know, as you're, did I write 2 different ones down or am I going to write 1, 7? Okay, yeah, both minus. All right. When you start seeing like those patterns, you should automatically, filing cabinets in your brain are opening up and you're going, okay, you know. And then also too, the directions are always kind of giving you that indication of where to go, and it's asking us here that our angle is going to be in between 360 from 0 to 360 degrees. Notice once again that we are looking for just the angle here, right? So that kind of gives you an indication, because you could do some modifications to go there, but why? Okay, so there's only one question to answer. What do you do? There's only one thing you really kind of can do.
Can't you just divide the whole number?
Well, yeah, see, that's like, if you can, the directions are asking you for where just the normal angle is. So, because that's the problem with math, yeah, because you can go, because what you're referring to is whenever we were like trying to find out, well, where's the half angle identity? But do we even have an angle yet? There's no definitive angle, so there's no reason to really, you know, look for something you don't. It's a variable, so we don't know where it's at. So the only thing really is to transform double angle identity into something more palatable to solve for, right? Because ultimately, the end of this problem, what we're looking for is something like this: theta equals stuff. That's what we're looking for. That's the overall goal. So if you have kind of like the whole eye on the prize, the end goal, that sometimes helps you make your decisions from this step to that step to that step, is knowing where you're going overall. So first things first, we have to transform sine, double angle, which, what is that identity?
1 minus cosine divided by 2, or square root.
And back up even more. I like this. Yeah, you got it. So when you have
plus minus.
Yeah, there we go. The plus minus, I think that's really helpful because it's such a key feature, isn't it? You know, like whenever you have, when you have that, when you say plus or minus, it all of a sudden instigates the rest of like what's happening. You're like plus minus, and then the rest of it just kind of rolls off the tongue. Sweet. We're on exam 3 worksheet number 7. I have like 1 through 5 like on a video that I posted. I'm putting timestamps. Do you have that link? Have I sent that? I've sent that in the group email, but I'll send it again so there'll be extra stuff. Anyway, so we're right here. Yes. So like the half angle plus or minus. You know there's a square root. You know there's a quotient of some kind. It's all being divided by. Right, what's here?
1.
1's always there. So like this framework right here, what's actually always here?
Theta, or cosine.
Yeah, there's a cosine and then theta, right? Or you can just think double that angle, right? Remember that I was kind of reinforcing that concept because that'll show up in calculus kind of like. And then here. Minus for sinus gets the minus. Even though it's sine gets the minus, but sinus sounds like it rolls better. Okay. Yeah, so then, yeah, we just we take that transformation and we just apply it. So we go, minus, what I like to do is I like to throw brackets in there to remind myself that this negative is going to apply to this entire transformation, right? And keeping that plus or minus is actually very, very important. So even though it looks weird, throw it in there and we'll see. And you always want to include it and just see by happenstance if it gets rid, we'll just go through the process. You'll see it'll either cancel or it'll be a problem. We've got, 0 right there, right? And then I'm just going to bring my negative cosine down right here. Okay, nice. One step closer. What's nice is now we have the same trig function, and remember, our goal is we want to get to something that looks like this. Theta equals stuff, and then answer, right? So what steps do you take to get closer to that? Theta equals answer. What can you do? So,
could you multiply the cosine, negative cosine?
Well, first, what is the problem?
The fact that it's even existing.
Yes, and then after that fact, what is the real problem? The thing that is like the obstacle in our way to getting to theta equals something. What is the biggest eyesore you could?
The plus or minus square root.
Yeah, this plus or minus square root's the problem. That's like the real big problem. So in math, when you have a problem, the intuitive thing is to isolate it and see if you can do something with it. Isolate your problems, just in general, right? Like it's kind of like in experiments when you have the control and you have the variable. You want everything the same, and so you can look at the one thing that's varying. So get this thing by itself. How would we do that?
You could add the cosine to the side of the zero.
Yeah, you could do that. Yeah, you could take the cosine over if you want to go that direction. So now we're going to be left with a minus, and I'm going to make sure that just to make it look better, I'm going to add cosine, is what y'all wanted to do, correct? To both sides. So we're adding this guy. Cosine plus cosine, that's going to minus out. We'll have this guy over here, that guy there. So we have minus, so this plus or minus square root 1 minus cosine theta over 2 over here. And in math, like if you get stuck, just start moving stuff around. And you'll start seeing, you'll be like, oh, okay. Yeah, now, like what could we do here? Square it. Does that get rid of all of your problems? Yeah, it really helps, right? Because like check this out. So I'm gonna use a brace because that's like the next larger one or whatever. That's how. So we're gonna do that, and we're gonna square this one, and we're gonna square this out. We're gonna square both sides. If you have a minus squared, what happens? Yeah, if you have a positive, it's positive. So it's going to eliminate, the sign completely gets negated whenever you square something. Sign goes completely away. All this trash right here, gone. Right? And then what happens to the radical when you square it? It goes away as well, right? Because you can think of it like this. That square that's being squared, that's being squared. Everything that's being multiplied gets squared. That's what's happening whenever you have, so a negative squared, positive. A plus or minus squared doesn't matter, it gets rid of it. Radical squared, it's gone. So now we're left with a 1 minus cosine theta over 2 is equal to cosine. I'm going to use that kind of nomenclature because it's saying that remember, this is a function, and this is the stuff inside of the function. The function is being squared, not the angle, right? The angle isn't being touched. The function's being squared. Okay? Awesome. So now what do we do?
Get rid of the 2.
Yeah, how do we get rid of it?
Both sides.
Yeah, awesome. We're gonna multiply 2 by both sides. And here you can see the 2's are going to cancel there, and we'll have a 2 in front of that. It'll be a coefficient in front of this guy. So now we're left with a 1 minus cosine theta is equal to 2 cosine squared theta all over. Okay, now it should start feeling like a little familiar, right? Because now what do we do? What do we do now? Yeah. Instead of taking all the little steps, what's our main goal? What are we doing? Whenever you see this pattern, you should some light should start kind of like picking up. Look, and what I mean is you got something squared, something that's not squared, and then a number. What pattern in math when you see something squared?
Oh, you can factor.
Yeah, you're gonna set everything equal to 0, and you're gonna see if you can factor or something like that. Quadratic formulas. That's what we're seeing right here. This is a quadratic. So we're gonna move this guy up here, and make sure it should be out of frame right there, right? Good, nice, awesome. Okay, so now I'm gonna move everything over to one side, right? And I like having this coefficient. I want to keep that positive, so I'm going to take all this garbage and I'm just move it over here. Okay, so I'm going to rewrite it where we say 2 cosine squared theta. Okay, since I'm moving that cosine over, that negative cosine becomes a positive cosine. And then this positive 1 becomes a negative 1. And then since I've moved it all over to one side, it's all 0. And you can also think 0 equals this, right? Just kind of like, how comfortable are you with moving it across? So I'm going to kind of do stuff like this to get you comfortable with seeing, seeing that motion or whatever. Okay, so now we're here. So what now? You could factor a cosine out, but it's not going to help you too much in this particular situation. Because this is what it would look like to factor it. If we factored out cosine out of everything, and I pull a cosine out right here, cosine theta, then we would end up getting 2 cosine theta plus 1 minus 1 over cosine theta equals 0. Right, because remember, whenever you factor it out of everything, it's like dividing everything out of it, right? So if I put a cosine under here, it gives me one of those. A cosine over that would be a 1, cosine over cosine is 1, and then you'd have to have, and it actually makes it a little more complicated, because now you have this and this. It's not a bad move, because sometimes, yeah, that's a great thing to do, but in this situation, when you get this kind of standard looking quadratic looking thing, there's really only one fail-safe, never going to steer you wrong, and it's called the something like the
Is it? It's like square root of a plus
that kind of stuff. Yeah, it's the quadratic formula, right? It's minus b plus or minus the square root of b squared minus 4ac over 2a. It's that thing. That's what you want to do, right? So we know this is our A guy, this is our B, because we're taking the coefficients, right? There's an understood 1 under that, right? And then we have C, right? And so now we take, do y'all know what is the quadratic formula? Wait, let's all together. What is, so it's minus, right? B plus or minus square root, there's that kind of feel, right? Whenever you see half angles, it looks like this. Plus, then we have b squared minus 4ac over 2a. Yeah. This, yeah, I know you're going on to higher math, you're going on to higher math. Trinity, what's your degree?
Pre-med.
You're going on to higher math. Everyone take a moment and just mental picture, memorize this. You'll see it forever and ever. It's not going away. This is something, they say write stuff like this on your bathroom mirror. These formulas, I'm not even kidding. You like get a chalk pen, and you'll get out and you'll like see that and you'll be like, yeah, okay. And I do that sometimes in my bathroom. I'll look like, what's that crazy movie with Jim Carrey? Like you know what I'm talking about? The number one where he goes insane with numbers. It's cool. It's a good movie. And then there's also like A Beautiful Mind with Russell Crowe. That's another one. Okay, anyway, so that's what we're doing. So we're going minus b plus or minus the square root of b squared minus 4ac has that negative 1 divided by 2, and then we have 2, right? Now, this has an equal, right? This whole thing equals 0. When you have this symbol, and I see this happen in algebra classes, what does this thing equal? Because people just will write to this step and then it's equal to what? And then you kind of keep going and you go, wait a minute, what did I even just do? What does this equal?
Cosine theta. Or, yeah.
Yeah, it's cosine theta is what it equals. Because remember, if these were x's in algebra and we had 2x squared plus x minus 1, if you just had that, on this left side, what is it? Would it equal? X. Right? Whatever the variable is. Whatever that variable is what's on this left side. That's what you're solving for. So, cosine theta is what we're actually looking at. Make that a little clearer here. So, equals cosine theta. That's what we're looking at. Okay? Now we just crunch the numbers. Now it should be k for the most part. Plus or minus 1 squared is 1, and then a negative is a positive, so you know a positive is going to be sitting there. We know 1's right there, because 1 squared is 1. Negative and negative is a positive. I kind of like to take care of it like that. 4 times, anything times 1 is just that, so you're just really looking at 4 times 2. 8. Over 2 times 2, 4. And let's not forget, this is all equaling cosine theta. Alright, so if we continue on down this path, a plus 1 is 9, the square root of 9 is 3. There we go. And so then we have a minus 1 plus or minus 3 over 4 equals cosine theta. And then, because of the plus or minus, we get 2 answers, right? And as you've gotten kind of comfortable with in trig, you always have 2 answers. Where is cosine positive? Where is it negative? And you're sitting there thinking about your quadrants. So now we have one answer where if we have -1 and a -3, if we had -1 and a -3, that's -4, right? -4 over 4 is -1. So we have a -1. And then if we have -1 plus 3, that's +2. 2 over 4 is 1/2, yeah. And I'm personally not really good at that stuff, and I use calculators for that. So don't I'm a counting on my fingers person still. I'm 5, 6. I count on my fingers still. Okay, so we have a -1 and a 1/2, +1/2. We have cosine. Okay, I'm going to erase this just so we can kind of loop back over here and not get out of the frame. So I'm going to erase this part here. And now we're looping back over here. From here, I guess here. Okay, so now we're sitting here and we're really saying cosine theta is equal to a -1/2, and then we have a cosine theta is equal to 1/2, right? And our ultimate goal was, where is the angle, right? Angle equals something. So what do we do to make that happen here in this situation? Yeah, we're doing the arc cosine or the inverse, and so you're sitting here and you're multiplying the whole thing by an inverse, that cosine inverse or whatever. The inverse cancels the function, leaving your theta by itself, and then you have a cosine inverse of -1, and over here, same difference, you have a theta is equal to the 2 equals. Cosine. It's how many equals do you take in your t? there, and we have 1/2. Okay, so for this guy, where is cosine? And basically that's what this inverse thing is saying. Where is cosine -1? Right? Because so in just I hope this is starting to stick in your mind's eye. Whenever you see a function right here and you have this, the normal trig function in here is an angle. And you get out a ratio. Or you can just think of this as like, you can also think of this as, it's just some kind of number. A ratio, it's just some kind of number, and I'll just do that. It's really, you have an angle coming in, and you get some kind of number coming out, right? If you have a inverse function, they just flip. You got some kind of number coming in, and it's telling you, hey, what kind of angle is coming out of that. So when you see inverse, and you get a number, you say, hey, what angle is that making? Right? That's all that's really happening there. So for this, you're sitting here thinking unit circle, right? And you're sitting here and you're thinking unit circle, and you go, where do I get a -1?
180.
Yeah, perfect, guys. Which is also, it's 180 degrees, or if we're talking radians, pi. Perfect. So degrees, radians, same thing. Awesome. Okay. What are yeah. Okay. So great. So one answer right here is both of those for this one. Okay. Now here, 1/2, positive 1/2, right? Because does -1 for cosine only happen in one place? Yeah. Right. Because there's only one place where x is. And remember, this is. If it's not in a quadrant, these are called quadrantals. Quadrantals are going to have like one answer, pretty much. Quadrantals, there's a formula whenever you see quadrantals. Cosine is equal to your x value over your r. That's kind of like that quadrantal thing. This is going to show back up in all of your calculus, this formula. Know this association, x over r. This is really going to help, because this is also what you use to transform between polar coordinates, rectangular coordinates, and in the future, spherical coordinates. You're gonna, it's all going to come back. So this, know that. So we got -x over r is always 1. Unit circle is a value of 1. -1 over 1 is 1. We are here. Nice. Okay. So same kind of concept. Where now are we in a quadrant here with 1/2? Yes. What quadrants are we in? It's positive. Where is cosine positive? 1 and 4. Beautiful. 1 and 4. We're here. It's even. Cosine's even here. Cosine's odd here. Even. What kind of angle gives us a 1/2 for cosine?
16,300.
Yeah, that's great. Quick. Nice. 60 and 300. That's a reference angle of 60. That's all I think is a reference angle of 60. So we get, yeah, that's great. So really over here we're imagining this. We've got, it's kind of high up like this and low right there. This distance is a positive 60 degrees, and this distance is a negative 60 degrees. It's a reference angle. It's just moving this way up here from 0 to here gives you 60 degrees. From 360 minus that gives you your 300. That's awesome. Great. And those are your answers now are those right there. If we're just in, hey, what's your radians here?
5 over 3 and 7 pi over 5. No, 7 pi over 5 pi over 3.
Yeah, 5 pi over 3. Why? Like, what's the quick way to know that?
Well, it's gonna be over 3 because it's.
Yeah, if it's over 3, it's over 3. It's over 3. If it's 60. Period. That's going to be your denominator. Here, remember here, this is 2 pi, right? Or 360, right? So just like here, pi, 3 pi over 3 is pi, right? So over here, in the same token, 6 pi over 3 is 2 pi. 1 less is 5 pi over 3. You're going 1 less. Right here, like if I wanted, what's my 60 degree angle here in radians? We're only going, how much more? 1 more? 4 pi over 3. See, that's the quicker way, right? If I'm up here and that angle is 60, what is my radians here? It's 1 less than that, 2 pi over 3. Do you see? It's really easy. It's like when you kind of organize it like that, it makes it way easier. You're not sitting there going like 120 degrees times pi over 180. You don't have to think that. You just go boom. 1 less, 1 more, right? Makes it nice. So they're your answers here. 180 degrees or pi. Here we had 60 degrees or pi over 3, and 300 degrees or 5 pi over 3. Because 1 more gives you 2, you know you're in the 4 quadrants. 4. Nice. Cool. Let's double check and make sure I answered that. And 7. And he was just, oh, I wrote the directions wrong. We were in radians. He wanted 0 to 2 pi. And in 7, he just got that 1 answer, which should be the only thing. You should have gotten more solutions for number 7. You should have gotten more solutions. Huh. So we got this correct solution. Sometimes if that happens, if this happens, let's see if this, when you double check yourself. So if you go back to the original problem, so we have minus cosine theta minus sine theta over 2 equals 0. Okay. So you may have to do this sometime. So we have these answers here for our theta equals, if we put theta back into cosine of pi is going to give us -1. So we have a -1 minus sine. If we put pi over 2, because we're just putting our pi, right, back to where it goes. Pi over 2 is what? Sine of pi over 2. Forget the negative right here. It's 90, but what gives you the ratio out of here? Sine of pi over 2 is basically saying, what's the value here for sine? Sine is y over r. The value is 1 over 1, right? So we have 1. So we have +1 minus 1 gives you 0, right? True statement. Check. This guy's true. Now, if we were to test these other angles, is what? Because I'm just wondering why he doesn't have another. The other answers in there. If he divided off, I may have to double check with him, but you should have these answers as well. Okay, but let's just see if it's true or not. So original problem, we have minus cosine, and we have our angle is pi over 3, and then we have minus sine over, if our angle is pi over 3, we'd have pi over 3 over 2 equals 0. So this means cosine of pi over 3 gives us our 1/2, right? Because we're just kind of working backwards, double checking. Here, you would combine those, so you'd actually have sine of pi over 6, right? This gives you what kind of angle? 30-degree angle, right? Pi over 6. Sine of pi over 6 is 1/2. That negative comes down, negative 1/2 and negative 1/2. Does that equal 0?
No,
It doesn't.
positive.
It's not a true statement. That's why these don't work. We got this is what's called, this is a great example, this is what's called an extraneous solution. These are extraneous solutions. Because when you enter in, this is actually a great teachable moment. When you're doing quadratics and you get plus or minus, you sometimes get more solutions than actually exist. So you have to come back to your original problem and you plug in your solutions. And that happens, the reason why that happens is anytime you introduce a plus or minus into your solution, you're adding something to the equation. When you add, you have to test. That's why only pi is the answer and not pi over 3, even though we still got that. Whenever you test it back in here, you get an untrue statement if sine is pi over 6. But we're actually not completely done, because if you have this angle 300, sine is what is this? Because you would end up getting your you'd get your 30-degree angle in the fourth quadrant, right? Do you see what's happening? If we put in 5 pi now, so this ends up becoming just entirely untrue. Because if you had 5 pi over 3 over 2, you get a 5 pi over 6, a sine of 5 pi over 6, which is actually still 60 degrees. Well, no, it's not. So 5 pi over 6 is how much? That's over here, right? Because you have pi you would be thinking 6 over 6. So you're going 1 less. You're up in here. You have 5 pi over 6. 5 pi over 6. Sine is positive, still is an untrue statement. Because you still get this same expression, you get a 1/2. Do you see what's happening? Sorry, I kind of went a little fast there, but I wasn't expecting an extraneous solution. But that's what those are. That's why there's only pi as the answer. Do you see what I mean? So, and I would hate to tell you all to test these every time, but the easy way to do that, the easy way to test is in your calculator. This is what you would do, is you would make sure that you're in radians, because we're doing radians here, or degrees, just depending on which one you grab. And you would plug the original problem in, and you would have negative cosine, and you would put your pi over 3 in there. And then you would have your negative sine, and then you would put you would have to put your solution, which I would still just keep the 2 and just put what you found. So you'd have like your pi over 3 over 3, and then that whole thing would be divided by 2. And whenever you enter that into your calculator, you'll find that you don't get 0. Absolutely. So that's why you can find out that they're untrue. That's one quick way. Sometimes you have to test the original answer. what would happen is if you wrote those, he would do that. He'd circle and be, these are extraneous solutions, and that's why. So when you test it back, you'll get an untrue statement. Anyway, okay, so that was kind of like.
So would he put it wrong, or just like?
These would be wrong, yeah. Because you would be giving somebody false information, basically, right? This is not a solution, but this one is. Okay, so you have to test sometimes back in the original. So hopefully let's move on, and we'll find. And I'll give y'all the quicker way in your calculator to double check. That way it's not like a whole nother math problem, right? Just checking your answer. So we'll do a little practice with the calculator. Okay, let's move on from that. Sorry, that took a long time. All right, do y'all want to do... Do y'all want to go on to like 9? That's the next, because y'all can have 8 for yourself, and we can move on to 9 for the next section. Or, what do you know?
I'm done.
Okay. Yeah, you're like, I'm done. Yeah, because we'll have tomorrow too. So I'm going to be doing one tomorrow as well. So feel free to, we can stay. This is all y'all's time. Sweet me. See you tomorrow. Yeah, have a good day. Cool. Where do y'all want to go from here? Let's do number 8, actually. Let's do that just to like reinforce this extraneous solution situation, because I think we're going to also get that here in 8. Okay, number 8. We have 0 equals minus 3 plus 4 cosine half angle minus 2 and then theta. All right. First things first, we want to get our variables all the same. We want this guy to be like that guy. So this
Plus minus the square root of 1 plus cosine theta over 2.
you said 1 and you said what was here?
Plus
Cosine, and then theta really, which is just twice that angle, so over 2. Right, we have minus 2 cosine theta, 3 minus equals, oops, that was 0. Okay. Then we're going to clean it up. And the easiest way is, and we're just kind of repeating what we did the last one. We want to isolate the problem child, square that bad boy, get rid of that radical. So I'm going to move this guy over. So we are going to take a plus 2 cosine to both sides, plus 2 cosine. And then I'm also going to go ahead and get rid of this guy. I'm going to say plus 3. I was looking at that number. Plus 3, and we're going to add this 3 on this side. So I'm going to bring that all down. So now we have a 3 plus 2 cosine theta is equal to, that zeroes out, that zeroes out. We're left with a 4 plus or minus square root of 1 plus cosine theta over 2. Well, yes. Oh, either way, you could either go ahead and square, or you could divide by the 4. Whichever way. What do y'all want to do? I would actually I wouldn't divide. The reason is because you'd get 3 over 4, and then you'd be putting that 3 over 4 into your quadratic formula, right? So don't make the fractions. I'm going to go ahead and square both sides. But there's still a way out of that if you did go that route. I'm going to square that. That should probably be braces. Okay. All right. So if we square this side, we actually have to do this kind of calculation here, where you're really talking about two of those now. So you have a 3 plus 2 cosine theta being multiplied by another 3 plus 2 cosine theta, right? That's those being squared. So if we do that FOIL, right, first inside, outside, last, so 3 and 3 is 9. 3 times that cosine, it's going to be 3 times 2 is 6. Cosine goes with it. Then you have another one of those, another 6 cosine. And then you have plus. Perfect. So that's what happened on the left. On the right hand, remember when everything is being multiplied, that square applies to every term. So 4 squared is 16. And then all that stuff gets rid of that plus or minus and gets rid of our radicand. So then we have this guy being multiplied now by 1 plus cosine theta over 2.
And then do you distribute that 16 into the 1 plus cosine of that? Or,
I would, 16 is divisible by 2,
so
right?
8.
Yeah, that's what I would do. And then I would distribute through there. So now, this guy all nice and tidy, we have a 9 plus, we can add these like terms, right? 12 cosine theta plus our 4 cosine squared theta is equal to, we distribute the 8 into both places. Yeah. Right? Now we're starting to get, you can see that quadratic thing. A variable being squared, variable not being squared, number. And then now you want to get into that squared, not squared, number kind of form. So now, 8, I'm going to get rid of him on this side because I want to keep things as positive as possible. So it's going to give me that 1, and I'm going to minus this guy off of that side. Because this also is a bigger number, so we keep things positive. And now we'll move up over here.
Can we do that, like if we get down to 1 quadratic formula on the side and it equals 0? If we can see it, like we can look at the equation
And see the factor.
see the factor, is it gonna feel bad?
No, that's like, yeah, because you can either see the factor, do the quadratic formula, or complete the square, which is like less often done. And if you can't, like the reason why I use quadratic formula is because it works every single time. And that's the only reason why I did that. If we see this one factor, let's do it that way. So we're gonna come up here and I'm going to kind of reorder it. So we have a 4 cosine squared is our highest term. Next, we have the 12 minus 8. 8, and here's me counting on my fingers. 8, 9, 10, 11, 12, 4. I do that still. 4 cosine theta, and then we'll have a plus 1 is equal to 0. Okay? Now you're sitting there going, can I factor it? And to me, it's like, I don't see one right off the top of my head, but
I just saw that the very last number was 1, so I knew that the last part of that was gonna be 1. And then
Yeah.
4, you can do 2 times 2, and then when I wrote it out and I did like the FOIL thing through my, I fold the fact that I just made.
Yeah. Yeah, let me know what it is, because I don't see it immediately. So you're saying you're doing,
I did that, and then I was like, okay, so there's a 1 on it, so it's 1.
Or they could be negative, but probably positive, yeah.
And then 2 cosine theta times 2 cosine theta.
Beautiful.
I think.
Let's double check. Gives us squared, right? And you have 2 gives us 4, and 1. Perfect.
Genius.
Nice. Yeah. See, sometimes like I don't see those as well, so that's excellent. So now you're having multiplicity here, because these guys turns out to be a perfect square. So you can set each one of these to 0. I'm just going to do them individually, because sometimes I get myself in trouble. Sometimes I'll lose information if I do the square thing. Right. So now we move the 2 cosine theta minus 1 over on both sides. Divide the 2 off, right? Cosine theta equal minus 1 over 2. Cosine theta is equal to, so this is just, we're just kind of doing the same thing. And now we're asking ourselves where cosine theta is negative 1, half. Okay, because whenever you're looking at your unit circle, you know it's a 60-degree angle. We have 2 answers here in this quadrant. We'll end up having your 120 degrees here. We're in radians on this problem. So we'll have our pi over, or 2 pi over 3. And then down here we'll have our 4 pi over 3 for 60-degree angle. Okay? But, and we'll double check and make sure everything is right. So what I would tell you to do is come back to the original problem, and then there's a store, it makes it easier. There's a, that's, I don't know if you remember, I was talking about a store key on your calculator. I don't, did you?
You never figured out how that works.
Okay.
It's a button, but I don't know how to use it.
The STO.
Yeah, the STO, if you were to take 2 pi over 3 and you went 2 pi over 3, and then you stow it, I'm going to try to, there's a stow button on your calculator somewhere, stow, and I don't know if you end up getting a calculator later at some point, that stow button, and then you can pick, there is a, did you find your stow? Yeah, and then me, I actually have a symbol for theta, that green one. So I hit alpha and then my green one. But you can sort as X, A, doesn't matter. You just sort it. And the reason why I say do it like that is because now when you can just straight up enter that problem into your calculator like normal. You can go -3 plus 4 cosine. Make sure you're in radians in this situation. Cosine, and then you can put your theta over 2 minus 2 cosine, and then that theta. And then whenever I press enter, I get 0 with 2 pi over 3. So check this out. I'm going to say, yeah, that's an answer. 2 pi over 3 is one of my answers. But then I'm going to re-stow. What's cool is I can keep that function, that expression in my calculator, and I just have to re-stow 4 pi over 3, and I'll hit enter to see if that answer remains true. So I say 4 pi over 3, and I'm going to stow that as my new variable, and then I just recall my answer, and then if you'll see here, it becomes -4, so -4 does not equal 0, so I have an extraneous answer. I only have one answer. Which this one's, sorry, that one should be an red X, not this one. So that's what you have to, and that's the quicker way. I don't know if you see like how I just stowed it as that, and then entered my problem once, and then when I restowed it, I just pulled my same problem up, and I kept the variable the same, and I get a -4. That's like a quicker way. Sometimes that's useful, because as you can see, you actually do have to check your answers on these. Cool? Did you find yours? Did you figure it out?
This is so cool.
What, the stow?
Yes, I
Yeah,
figured it out.
it's so worth it because it's going to help you in. It's just going to help you. Like, it's one of those little extra tools that, hey, that's going to take you from a B to an A because you're going to double check yourself. Doesn't take much time. Boom. Yeah. So check. So name in the game here, you guys already know in trig. Okay. So main idea in trig equations. Remember whenever we couldn't divide off the trig function because we'd lose information? Well, now we're on the other end of the spectrum where we're getting more answers than we need, extraneous solutions. So you have to be very careful essentially with these trig equations. And the main idea is when you enter in a plus or minus square root, the possibility of extraneous answers are going to happen. So that red flag should kind of pop up when you see that square root. And the reason for that is when you square something, remember how the sign went away? Like if you square a negative, right? But as you see on the unit circle, it matters where we're at. So when you square, because when you get rid of that, you're squaring it. So you're getting rid of the sign, and that's what's causing the extraneous answers. Because is it plus or is it minus? That's kind of what's happening, more or less. I'm not explaining it super well, but that's sort of like the thought process behind it. Okay, great. Nice. Okay, I'm gonna erase this guy. So I'm also a little tired today, so I might be like, I don't know what my speed is right now. It's not. But once again, we can have practice sessions over the weekend to get ready. I'll have all the videos I'm posting as I go, so you'll have those as resources. Let's see, we're at 7 o'clock. What do you guys want to do? You want to continue, press forward? This is y'all's time. I'm here for y'all. Going home? Yeah, because we're doing math all day long. It's a lot to do. So, okay. Were you gonna try to come to any on the weekend? If not, I'm gonna be recording them too, so they'll be so.
I can't come tomorrow because I have an interview.
Yeah.
But on Saturday, what time Saturday?
Friday is gonna be 1, and I haven't made a Saturday yet, but we can do one if you want.
On Saturday, I can't go if it's like between 1 to 3 if I go to church.
Okay.
But on Sunday.
Okay, cool. Will you just email me that to remind? Because I may ask people if everybody wants like a Saturday session, I'll do one. Or even if just one person does, I'll do it. So yeah, for sure. Well, I'll have the videos up. So, and also email me if you get stuck on something, dude. Email me. And like I'll this weekend I'll just be next to my computer chilling because I'm probably just gonna be gaming. So I'll see that coming up because that's. Do you want to keep going, man, or what do you want to do?
I'm gonna try to do one more. So.
Okay. Cool. Well, I'll turn the camera off to keep the length down.